Now let us discuss about the most important topic, that is sorting techniques. There are many number of sorting techniques that we are going to use and we are going to discuss in this playlist. Now, what is sorting technique? Sorting technique is nothing but you will be given some array. You will be given some collection of elements. You need to sort them in order, like in ascending order, right? That is what sorting technique means. So there are many number of methods that was made in order to sort. So there are actually 11 sorting techniques that we are going to talk about. In this lecture, I'm going to give introduction to sorting techniques, like the time complexity involved in all the sorting techniques, and which is good and which is not preferable, and everything we are going to discuss. So sorting techniques. So okay, sorting, there are 11 methods, as I said. Broadly, let us differentiate these sorting techniques into three classes, like three types. These sorting techniques that takes big O of n square time, right? The whatever the sorting techniques I discuss here will take nearly big O of n square time. That is maximum they will take big O of n square time. The time complexity is more obviously. Then this actually there are four. Let me again distribute this thing. Okay, this second class will take big of n log n type, big of log n log n type, and the third class will take big of n to the power of 3 by 2, that is big of n to the power of 1.5. That is what the time it takes. And the last one will take big O of n, and this is most efficient in terms of time. Again, I am going to specify that in terms of time complexity they are better, but in terms of space complexity they are not good. So let us discuss about these four techniques. First of all, big O of n square. Here there are again three different sorting techniques. First one is the, as I think you will be heard of this thing, that is, let me increase the size, let me make it as 26, 20, let me make it as 48. So the first one is bubble, B-U-B-B-L-E, bubble sort. This is the first one, and usually you will be heard of. Then second one is insertion sort, and the third one is limit selection sort. I think these three are common, and people will be heard of these three sorting techniques. And the next class, let us discuss about the next class. That is there we have four types actually. First one is heap. Let me again increase the size. Let me keep it to okay, heap sort. Then next one is the tree sort. Next one is the merge sort, MERG, merge sort. And next one is quick sort, QICK, quick sort. So these four sorting techniques comes under big O of n log n time. And here we are going to discuss here in under n to the power of 1.5, big of n to the power of 1.5 time. We have only one thing, that is shell sort. That is shell sort. And at the last class that we have, we will be having again three division. Those are first one is the count sort, COUNT, count sort, and second one is the radix sort, and third one is the bucket, BUCKET, bucket or bin sort. So these are the 11 sorting techniques that we are going to study, right? So as I said, this will take obviously more time, and this will take obviously less time, but there is again difference between these three classes and this class. These three classes, what they do is they compare, right? They will compare and they will sort. So comparison and swapping, these happens usually in these types of in these classes. So the time complexity usually will be high. But when we are talking about this class, here we use index based sorting. Index. So whenever we are using index based sorting, obviously uh, the time complexity will reduce, but the problem is the space complexity will drastically increase. Means based on index, your the values you will consider it as index. Like if you have 2 3 4, then you are considering 2 3 4 indexes. But what if your value is 100? Then you should take again increase the size of the array or a linked list, anything. So you will have problem in space complexity, but time complexity, this is the best thing. So again, if you are not getting which one is greater, like n square is greater, you know that which is the next one. This is the least, big of n square is greater, right? Among these two things, which is bigger? Obviously n to the power of 1.5 is actually bigger than n log n. So big O of n square will be normally greater than big O of n to the power of 1.5 or 3 by 2. Then it is that will be greater than big O of n log n, and that will be again bigger greater than big O of n. So it will take linear time complexity. So this is about the basics of sorting techniques. And again, while sorting techniques, I will be discussing some of the criteria that decides which is efficient and which is not efficient. So some sorting, like the criteria I'm going to discuss now. The first criteria what I'm going to discuss is the adaptation. That means how adaptive is that sorting techniques. It is adaptive, and I am going to explain you what is adaptive means. And second one is stable. Stable is again another sorting criteria. Third one is the memory, extra memory. What is it is taking, whether it is taking extra memory or not, right? This is what again another one is. And number of comparison and number of swap is other two criteria. Comparison, and last one is the swap, number of swap. These are so much important when we are considering which is efficient. So adaptation means what? Adaptation means it should be adaptive. Like what if you send for a sorting technique? Imagine you're using some sorting technique. Imagine you gave the input as 1 to 3. Like you have already sorted the element. So that sorting technique should not take usually the time what it takes, actual time what they take, like what I discussed here, the actual time what they take, they should not take that much amount of time. If it is sorted, it should take the least amount of time, like it should return instantly what it is already sorted, like that. Those are the techniques are called as the adaptive techniques. What is stable techniques? Imagine I have sent a value like 1 3 3 and again some value like 10, again 7. This I have sent. It should sort, right? It should sort, but it should not change the position of this 3 and this 3. Actually this 3 and this 3 has no difference in terms of data what they have, but they should not change actual position of this 3. They should not be exchanged or anything. This it should not happen. Extra memory, like we are going to discuss whether it, like in this case in the fourth class, it will take so much extra memory. That is what not a good thing. So even that criteria we are going to consider. Then number of comparison, that is also so much important. So how many comparison you are doing in order to sort, right? And what are the swapping? This is swapping, number of swap that you are doing. So what are the how many swaps you are doing? So these are the criteria. So in next session I'm going to, or if you are you can find in playlist, I think in playlist you can find in order. I will be posting all these coding, all these sorting techniques theory, and even coded, I will code that in code blocks, so that will be easy for you to understand. And thank you.